Okay, we'll move into the diagnostics and testings of these systems. Pre-diagnostic inspections would include a test drive. We probably want to find a nice, quiet, straight road where we can apply the brakes so we know the ABS that are being applied. We might want to accelerate quite heavy to make the wheels traction spin a little bit so we can see the traction control coming on. Probably then bring it back in and use our scan tool to go through and make sure that there's no fault codes or anything out of the ordinary that we see. And if we do have a fault code, we'd want to go and investigate where the fault code was. If it was a wheel speed sensor, we probably want to check live data on our scan tool to see if the wheel speed sensors are registering. It could be an intermittent problem sometimes. Okay, so here we're looking at the scan tool. We've got a couple of fault codes of traction control P0856 and a U code. What's a U code?
Communication.
Communication code, yes. So could they be tied in together? Could we have multiple faults, or do you think it's tied in together? AURTTA125, which says no CAN bus communication. Very likely, couldn't be. Very likely. So what would we do? Which code would we look at first?
The PO?
I'd probably check my communication code first to see if that communication was working. We could record the codes, see if there's any freeze frame and clear those codes and see what returns as well. And if both of them came together, then I'd definitely look at the CAN bus code just to see if we got a communication problem. How would I check the CAN bus?
Through the scan tool?
We can. How would I do that?
Live data? Or probably freeze frame? No.
What happens if we do a full scan of the vehicle and scan we probably should have done that at the beginning, of course, but we would soon see if there was a module that was not on the CAN bus, wouldn't we? So that's one way. But if it's an intermittent problem or a corrupted signal, we'd probably use our oscilloscope and check the wave pattern and have a look at it that way. All right. So, diagnosing and testings. We'll continue with this vehicle. This is a live vehicle. It was a Toyota Corolla. The EPS warning light was on. No electric power steering assist. So the power steering, when they're electric, they're also part of the traction control. And your steering angle sensor and all that is all part and parcel. There was a power problem, as initial relay was not powering up the electronic power control module. So that was the end result. Okay, that was what was wrong. The process of fixing this, we had, this is, you know this person?
Yeah.
Yeah, Jeff Smith. So Jeff, this is in his workshop down at Sydney, and he's
the one who built a electric starter.
Yes, that's the one, you know him, yeah. So let's see what he's got to say.
Hi guys, Jeff here from TAP. Just had an interesting car in the workshop today which we've now completed, but I just wanted to share with you as we've just uploaded a repair solution for this vehicle. It's a 2010 Toyota Corolla. It's coming with the electronic power steering fault. So again, well, I think we've done a video on one of these before where the modules are located up in the centre of the dash area, so the dash pad has to come off. They're mounted up the top there. That's a picture of the actual module that's mounted up on the top of the dash area. And again, the common issues with these are they're coming up with fault codes for different modules, but it's actually inside the printed circuit board. So you can replace it with a new module, etc. Or you can go around now and actually replace the actual relays inside the control module. So you can see inside here with some of these we had the pitting of the points inside the relays. So there's two relays located inside this particular module, and they're the parts that fail. So you can desolder them as we've done here on the printed circuit board, and then mount it up new relays which are available. So we've got the part numbers on this particular repair solution, and we'll put a link to that repair solution on this Facebook post. But again, you can desolder and resolder those relays on there, either 40 amp or you can even go to a 70 amp relay, which is a bit of a modification on the pins, but you can make them fit into that printed circuit board. So if you want to repair it yourself, and that saves any programming issues, because guys have refitted second-hand ones with literally the same part number, but then they've got some hard fault codes in there in regards to compatibility of that unit in the car. So repairing or replacing those control relays inside these modules are well worth the effort and things. As I mentioned, we put the part numbers of those relays in this repair solution, which is now up on our website. So if you're one of our members, please make sure you're utilising these repair solutions, which we're adding about 20 per fortnight into the system. If you're not a member and you want to get access to this information, just go to tap.net.au and click on the sign up now button. See you next time.
So here's some pictures in a minute coming up. Pictures that he was showing on those papers. You can see the module, you can see the relays, you can see the pitting. See the pitting in the contacts there?
Yeah.
And I think this one here was one was a 40 amp, I think, and one was an 80 amp. I could be wrong. But yeah, he said he can modify that one to fit too, which is maybe a better idea.
He's a very smart guy, eh?
Oh yeah.
Because I spoke to him and he explained everything about the starlet, the electric starlet.
Yes.
It's a manual gearbox.
Yes.
And he converted everything over.
Yeah.
So he showed everything, like when he bought the car.
Yeah.
And he started.
He's just started a new association with electric vehicles now. So and he's helping technicians who want to work on electric vehicles to be able to transition over. All right, well, let's look at another diagnostic problem. So we're all about diagnostics at the moment. Okay, sorry, we're still on the same one. These are the part numbers, right, of those relays. So it was a 40 and a 70 amp. I said 80, but 70 amp.
Yep.
So that was on his website, on the TAP website that he put those numbers on, the fix. So we'll go over to this next diagnostic problem. This is Rob, he's another TAP member. He's in Perth, by the way.
G'day guys, it's Rob from TAP. Just got a really quick one in today. We've got a Mazda 2 that's come in for an ABS light on. So the customer actually had already replaced the right hand front wheel speed sensor and it did not rectify the problem at all. So we've actually repaired the car already. What I'm going to do is I'm just going to take you through the very quick process of what we found and how we rectified it. So stay with us. So yeah, firstly what I want you to look at is the state of that connector. So what we did is obviously we probed these two wires as we are now, and we just wanted to confirm being a magneto resistive active type wheel speed sensor, we needed to make sure that we had power on one side and ground on the other side, and obviously on the vehicle side we do have that, as you can see, 10 volts. But what we did find is on the other side of the sensor there was no battery feed from the actual vehicle side, and the reason why is this connector was damaged and the terminal tension was actually too great and it was not touching properly. So but look, I'll just pull this out and I'll just quickly show you. There was a massive cable tie holding it on. If you see now, I can basically almost pull that apart. So that's completely broken. You know, we've tightened up those terminals and all is good now, so that is rectified. What I'll do is I'll show you what it looks like on a scope if you've never seen a magneto type active wheel speed sensor with a digital square wave instead of your normal AC type sine wave. So I'll connect the scope up, put in AC coupled mode, we'll get it up and we'll get the Verus on there too, and we'll look at the live data. And you know, that's how we did it. You know, look at the live data first. You can see we're getting no signal. And then we came down here with the wiring to confirm that integrity there, and there obviously wasn't any. So yeah, like I said, we repaired that that terminal tension. We're going to fix up that connector as best as possible, but we are going to recommend a new connector, but I will show you what it should look like. So we are back broken to the sensor, obviously our signal wire from the Pico on the positive side of the connector, and our ground leg of the Pico to the ground side. And firstly, we just confirmed that that's what we're seeing on the scan tool, wheel speed sensor right hand front. Now we've got a reading at 22 kilometers an hour. And then we go to our scope, and now you can see that we are AC coupled for this sensor, and as you can tell there, we have a great digital square wave. But it's always important to make sure you're using the ground of the connector, because what I'll do is I'll change the ground to the body and I'll show you what it looks like. So we'll disconnect that, we'll put it to the body, and look how hashy that is. So you know, if you just got this signal up with the body ground, you may think to yourself there's interference going on and there's an issue, and that's why it's not reading properly, but that's not the case. So that's all repaired, and yeah, just a really simple one, this one, guys. Just to, you know, it's always a good idea to be making sure that we're checking the connector area before we ever replace a component, just in case the component wasn't faulty in the first place, which this one may not have been. Obviously we didn't get a chance to test it beforehand, but now we have, and the vehicle is repaired. So there we go, guys, a very simple and quick one today, but it just shows the importance of making sure that we're checking connectors and wiring before we start replacing components. Like I said before, the last thing we want to do is obviously, you know, ring the customer up and we get an ABS light on and we automatically assume that the sensor's faulty, ring the customer, sell them a wheel speed sensor, fit it, and it doesn't fix the problem. So just pays to do our due diligence and make sure we, you know, 100% rectify the fault. So thanks for watching, guys. We'll see you next time.
So yeah, a simple connector can cause all that problem. And people who just look at the scan tool, whatever wheel speed sensor it was, faulty. Oh, let's put a new one on. And guess what? Didn't fix it. Why? Because it wasn't that, it was a connector. And yes, he said he would recommend a new connector. I'd be stipulating that it must have a new connector because yeah, it allows moisture and stuff to get in if you don't replace that connector. But yeah, all right. This was a car that came from Hertz. Hertz was a customer of ours that we used to do a lot of their rental cars. And this car came in with a complaint that the engine mill light was on, as well as the traction control was disabled. It'd been to the dealer had looked at it under warranty and discovered that it had one of those tracking devices that were put in by the Hertz to track their vehicle, and they were blaming this aftermarket installment of this tracking device, the GPS tracking device, to be the fault, so it would not go any further and said it would not be under warranty. So I took over the vehicle. We put a scan tool on and we found that, we put a scan tool on and we found that we had the fault code P0500, which was present, okay? And that was to do with the vehicle speed sensor. So it had a vehicle speed sensor related type fault. So that was where we started, and we used that to, we needed to rule out the GPS tracking device first. So we did disconnect the best we could that tracking device. Later we were a bit concerned that maybe, you know, the wiring was still intact in some of it, that maybe there was something that was robbing from another circuit that was causing a short to circuit, short to ground or short to power. So we actually got a wiring diagram, as you can see in this slide, and that wiring diagram gave us the information. It was not that complicated. We discovered that there was no vehicle speed sensor reference coming into this module, so that was positive. And all the powers and grounds we checked, they were all sound. So we pretty much ruled out that it was this tracking device and needed to move on from there. So, you know, after we did that, we carried on and we got a factory wiring diagram just to familiarise ourselves with how everything worked. Thought we knew how it worked, started doing our testing, doing our voltage testing and checking things as seen in the picture. We could see that we had a vehicle speed coming out of the wheel speed sensors, going into the ABS, and even coming out of the ABS, we found all that was working properly. Signals were coming through. And we found it would go through to the instrument cluster, but we had no reference coming into the engine control module. So this is my suspicion that possibly the actual instrument cluster could have been the actual reason for this problem, and that's where I was starting to think. So I contacted the dealership that did the work, actually got the advantage of talking to the technician. That technician was able to set me straight on how it worked. What I didn't understand was, once I understood it made sense, but what I didn't understand was that the signal from the instrument cluster goes to the engine control signal by a pull-up circuit. And that pull-up circuit is what pulls down or pulls up the voltage from the speedo sensor, and from that reference voltage it will then have an output and know what the the road speed of the vehicle is. And I found out I didn't have that 5 volts coming out of the ECM going to the cluster. So that was where our problem lay, and I could test this at the cluster. So now that I had more information, I was able to move further forward. And after a lot of time spent trying to locate the problem, ended up being an open circuit caused by someone pulling out a spice plug. A spice plug is where you have different connections coming and are joined together through a spice plug. And it's a great testing spot if you want to test your CAN bus system and different things. And it was in that spice block that was disconnected and left out that was causing the problem as an open circuit, is why I lost my 5 volt reference. And we couldn't buy a new spice plug because it had to be bought with a whole wiring harness. I think I bridged all the terminals, just bridged the terminals that were left open, and everything worked fine. And I think later on we bought a second-hand plug we were able to buy, and we were able to fix that problem and continue. But that was a very tricky problem, and it affected really the traction control unit and probably other things as well. So.
Hi guys, Jeffrey from TAP. We're doing an interesting job in the workshop today, this Ford Ranger with ABS traction control problems. Had this car presented to us today with an intermittent traction control ABS fault coming up with the warning light. It's a 2013 Ford Ranger, or that PX model, so in that range, 3.2 litre, but it's a common issue with the rear differential wiring. So if it comes through, I can show you exactly what happens on this particular vehicle, and we do have a case study up on file for it. This harness here, we've got it on the hoist, so it's dangling down, but you can imagine once it's up, it's moving all the time. So this harness is going like this all the time, especially if it does a bit of off-road stuff, and eventually it breaks this wiring in here. So if you've got any issues with these sorts of vehicles, make sure you have a really good look at this wiring harness here and at the top, because that's where they traditionally break, up at this point, or even more importantly right here at this point here. So again, any issues, probably would suggest if you're working on one of these vehicles is to have a look at it when it's on the hoist. You're in for a service, have a look to make sure that wiring's in good order. They are commonly breaking in that particular point. As I say, we've got a case study already, a repair solution on our system, which we'll highlight as well, but that's the common area to make sure we have a look at. I suppose we've got any car on a hoist nowadays with ABS and traction control and things like that. Having a good look at wiring harnesses when you're having an inspection of a service is a great idea, especially looking at those pivot points where wiring has to pivot because it's on an axle or whatever, and so you're getting that wiring movement all the time. Hopefully that helps you out. If you're a TAP member, don't forget to utilise all those repair solutions. If you're not, maybe go to tap.net.au and join up with the many other thousands of technicians and workshop owners, etc., sharing information, knowledge and experience. See you next time.
So pre-diagnostic inspections are all very important, as I say. We want to always go through the process that we have. We want to observe that, and verify that the brake light or the ABS light or whatever is the customer's complaint is a real complaint. Something that I probably don't highlight enough, but it's very important, is to always check the fluids. Okay? If we're talking about ABS and the light's on, and I had an actual case of this vehicle, I said to you earlier, I used to do a lot of Hertz work. They had a fairly late model car with the ABS light, traction control light, everything coming on, and all it needed was a top up of brake fluid, and that was fixed. That simple. So yeah, it's important to check your fluid levels. Check your fluid condition too, if it's contaminated, that can tell you a lot. I mean, if we're doing an engine diagnostics, we always check the engine oil. We always check the coolant level and the condition of both coolant and engine oil. It's the same with our brakes, okay? We need to check the condition. Test it for moisture. Could have a lot of moisture in it. Inspect the hoses, the lines, the fittings for leaks or damage, okay? Sometimes people have been bush bashing their vehicles, and they've, something's stretched and they've got a crack in their hoses or the whatever, who knows? Even that last video we saw with Jeff, that he's showing you where the vehicle goes up and down and how you break that wire over time, check things for that. Inspect all the brake components, that's something's down to metal, or we have these brake warning lights now that come on when the brakes get down, and that could disable the brake traction control and ABS. Check for loose wheel bearings. Wobbly, because that's going to throw the wheel speed sensors out if the wheel hub's moving like that. Check your outer CV joints for alignment. Check the tyre treads. we're talking about, you know, keeping the tyres fairly even so that the ABS traction control, if something goes off, it will pick up on the different wheel speed and try and rectify the problem. But if we got low tyre or baldy tyre, we're going to have more slipping in that tyre, aren't we?
One of my favorite tools is, you know, the mechanical stethoscope.
Yeah.
And then,
Listen.
you know, now I check the wheel bearings like this.
Yes, you
Speed
hear it. That's
and
right.
hear it. And you can literally hear everything.
You can.
And the alternator is making noise,
That's
the
right.
pulley is making noise, you
Yeah.
can
pinpoint.
and So
Definitely.
one customer came in the other day and the customer is saying, oh, I think my alternator is making noise. I said, no, your AC compressor is making noise.
Yeah.
So that's a very good tool.
It is. Yep. Sometimes noises do transfer. For example, a diff noise can transfer up the tail shaft.
Yeah.
You think it's coming from the transmission, it's really the diff. So you can get caught, but just, it is a good tool. So also tyre pressure. Make sure our tyre pressures are even, okay? We'll obviously look at all the electrical wiring and connections, look for damage or corrosion. And inspect the actual wheel speed sensors and wiring at those sensors too, okay? We've got to test drive the car. So begin with the brake pedal feel. Is it feeling good? Is it stopping well? Is it stopping correctly? Accelerate maybe up to 25 or 32 kilometres an hour and then apply the brakes. Note if there's any pulling in the brakes or swerving. Test the low speed activation of the ABS, you know, to make sure it's working low speed as well as high speed. So all those things we need to vary and check. We do we look for any malfunctions through the scan tool for the ABS system, obviously, and the traction control. So we do a check. Each system, we make sure each system in the diagnostic modules, you know, not just the traction control or ABS. We need to check all the systems, so do a full scan of the vehicle. And always refer to manufacturer specifications.
Yep.
Okay, and process and procedures, you know, we talked about bleeding procedures. Well, there's also diagnostic procedures, but use a logic thinking, you know. Sometimes the manufacturer might want to take you down a rabbit hole some way by doing all these tests that aren't necessary, so use your logic as well. A critical ABS or input for the wheel speed sensors signals can be, you know, so critical, so make sure they're okay. You know, some sensors, some wheel speed sensors are the AC generated ones, which were the most common ones, but we learned in that video that there are digital ones now out there too, wheel speed sensors. So some of the vehicles now, which are more newer now, are using the Hall effect sensors, which are digital sensors, or wheel speed sensors. So just to be sure that we don't, when we're looking at our oscilloscope, for example, we know what type of sensor we're looking at to expect what sort of pattern. So here we've got typical AC reluctor type sensor, wheel speed sensors, and we can see a good sensor and a bad sensor on the screen. Yep. So this being the bad sensor, so it's quite obvious from good to bad once you get used to what good looks like. Oh, by the way, go back to that one too, and the fault of this one was a bad toner wheel. Okay, so it wasn't the sensor; it was a toner wheel. So we can get caught with thinking that's the sensor, it's a toner wheel. Sometimes I like, not always you can do this, but some cars you can swap left to right. And if you can, and they're easy enough to do, it's a good test. If you transfer the problem over, you know it's a wheel speed sensor. If the problem stays the same, you've got a harder problem, such as a wiring problem, or in this case, a
So that means that the toner ring was broken?
Possibly, yes. Doesn't actually say, it just says damaged toner ring. But yeah. So with the wheel speed servicing, the wheel speed sensor servicing, just inspect for any maybe chipped or cracked pulse. The teeth going around, check the teeth are okay. You can use a feeler gauge to check the air gap, because we talked about the air gap, okay. Look up for a lot of rust or corrosion or dirt or brake dust, look at that as a possibility and clean that up. And obviously the pulse magnetic generator sensors, the wiring is twisted in pairs. Why would it be twisted in pairs? That's to stop the noise, okay, the noise, the radio interference from the other components in the electrical system. So let's make sure that's okay. There's a damaged toner wheel. See it cracked? Pretty rusty looking at the actual system, but yeah, possibly. If that was a new CV joint, I'd possibly say they got damaged when they fitted the new toner wheel, not the new one, but they swapped the toner wheel around. But because that's so rusty looking, there's obviously other reasons why.
Very.
So, you know, if you see a new CV shaft on an axle that's got a toner wheel like that, obviously be suspicious, because some of the toner wheels had to be removed and refitted to the new one. They might have put it in properly. So inspect for rust, check for cracks or missing teeth. So looking at bleeding the brakes out, always refer to the service manual attempting to bleed ABS brakes, okay, because there'll be different systems of how they want you to bleed the brakes, all right? And here we go, ABS bleeding procedures. So there's, even the scan tool sometimes will tell you and give you the sequence, okay, and that's fine. So we select, like these are different things we select, but here we are selecting ABS motor. Special function. So here's some knowledge questions. Technician A says the ABS system may require special bleeding procedures. Tech B says integrated systems may require depressurizing the system before servicing. Who's correct?
Both.
Both are correct. Good answer. That was quick.
Because obviously you have to depressurize the system.
That's right.
And then you have to follow the procedure for bleeding.
100%. Yeah. Okay. So some new trends around. Okay. Electric calipers. Okay. I haven't seen them, but there's obviously in the pros of happening. So the computerized control to eventually, that'll be interesting. Electric to take away a lot of problems, wouldn't it? No bleeding anymore.
I haven't seen electric calipers.
I haven't. No.
Must be all in this newer car.
So it would make more sense, wouldn't it, if we had electric calipers to have better control over everything, you know. And brake by wire. What am I talking about? Brake by wire. Okay, that means that there's no hydraulics, which is virtually what electric brakes are in here. So brake by wire, commanding an electronically processed and the master cylinder control. So there'd be no brake, or there'd be a brake pedal, I guess, but no link between the brake pedal like we have with hydraulic master cylinders and whatnot.
Yeah, I just saw the electric brake caliper.
You did? Yeah. So there you go. It's coming. And there's a picture of the electric brake. Brake by wire would be ideal for hybrid cars and electric cars, obviously. And brake pedal sensors would determine driver intent. So if we're going to put a pedal down hard, that's our intent to stop hard. So we still have some sort of system that would feel like a normal brake pedal, but it's not like a normal brake pedal. Okay, so yeah, interesting what's ahead of us. Wet brakes. This is interesting. We have, I guess, a certain amount of loss of braking when we have wet roads because of the water, okay, and until the brake's dry. But now we've got systems, just like we have rain sensors on our actual wipers now, they've got the same on the brake caliper, so that if they sense water on the brakes, they will just lightly put the brakes on, just very lightly, just to dry them. That's the only purpose, in case we need emergency braking. It's pretty amazing, eh? So, and guess what? We've come to the end.